This episode of Real Engineering is brought to you by Brilliant, a problem-solving website that teaches you to think like an engineer. We've been hearing about it for years. The 21st century is the era of urbanization. In almost every country around the world, people are packing their bags and moving into cities at record rates. This is a global phenomenon across the spectrum of developed and developing economies. Approximately 54% of people worldwide now live in cities, 30% more than in 1950. And projections show that urbanization, combined with the overall growth of the world's population, could add another 2.5 billion people to urban populations by 2050. In many countries, the largest cities are growing faster than their smaller counterparts. Rural cities, towns and villages are being cannibalized to facilitate the demand for jobs in these urban centers. For better or worse, we are increasingly becoming an urban world. Thus, it's no surprise that the demand for city housing is skyrocketing. Prices to rent or to buy are reaching for many unattainable highs. Savills, a global property firm, published its list of cities with the highest cost of accommodation around the world, with the usual suspects ranking high. New York, Hong Kong, London, Tokyo and Paris all consistently in the top 5. But even smaller cities like Dublin are experiencing serious housing crises, with many people unable to afford to live near their places of work. With jobs flooding back into Dublin after years of recession, there is incredibly high demand on urban housing. In Ireland's capital, housing prices have risen by an average of almost 50% in 5 years, and the number of listings are at a record low. Some attribute Dublin's housing price increases to a lack of housing supply due to investors hoarding property, an increase in Airbnbs, or vacant land not being developed. While these are all definitely factors, even if they were resolved, Dublin would still be falling short of the 25,000 new units needed every year to meet the current demand. In recent years, construction in the city has increased significantly with the return of cranes to the skyline. But many are commercial units and apartment buildings are simply not being built fast enough and in enough numbers to make a dent in the demand, causing rent prices to rise to the point that many young Irish are once again having to consider whether Ireland is a place they can build a future, continuing the ritual brain drain of our country's youth to not-so-green pastures. The government has responded to this problem unsuccessfully with ridiculous attempts to ban rents from rising, a solution akin to banning a sick patient's temperature from rising. The only cure for this fever will be to increase the supply of housing. That is, increase the supply of housing while minimizing cost. Let's first focus on optimum height. While some are calling for high-rise buildings in Dublin with the idea that it will lead to increased density and greater supply, buildings that are too tall don't translate into affordability as they cost too much to build. In theory, taller buildings reduce square meter costs of floor space the higher you build and increase the overall returnable revenue from a single plot of land. However, the cost increases as you build higher and higher. Lift systems, fire prevention measures, water supplies and pressurization, and heating and cooling systems all add to the cost of high-rises. Costs like these lead to a U-curve in regards to the cost per square meter and height, where the cost per square meter initially decreases with an increase in height and then starts to increase after the height reaches a certain point due to the increased engineering demands. Every curve therefore has a bottom out point. This bottom out point is different in every city and varies widely even within the city. But on average, the lowest cost per square meter in Shanghai and in the Netherlands, for example, is around 8 stories. In Hong Kong, thanks to the limited land area increasing land cost, it's around 12 stories. The additional cost of engineering can be marginalized by high costs of land, making it worthwhile to build higher. Take the extreme example of 432 Park Avenue, the tallest residential building in the world. Built on the site the historic Drake Hotel once occupied, centrally located with Central Park views, the site became one of the most valuable plots of land in the world at 520 million. Now it goes without saying, this building was not constructed for the average man. It has over 85 floors with 38,000 square meters of usable floor space, but only 104 units for people to live in, each costing millions of dollars each. But the point stands, where there is exceptionally high demand, you can build higher. The cost of land in Dublin doesn't come close to those of Manhattan or Hong Kong though. So in most cases, the bottom of our U-curve, i.e. the most cost-effective height to build to, will be between 6 and 8 stories, with a recent Irish government report even suggesting as high as 12 stories in some areas. Let's next focus on minimizing the building cost of these buildings. One of the primary causes of increased cost with increased construction height is the necessity of using floor space for the structurally integral building core, which keeps the building standing and houses elevators and other services. While there are many ways to design the shape of the building, certain floor plate designs end up being more desirable than others to maximize usable space. Say that the net area of the floor plate of this building is 1400 square meters. The core of the building of this shape and size would need to be around 335 square meters. This gives a gross area of usable area of 1065 square meters, and thus a net to gross ratio of 1.31. So a design like this is stylish, but when you analyze the space efficiency, it's not great for maximizing floor space. A building like this seems like it might have a bit more usable space, but the building core is still taking quite a bit of space compared to the livable floor area. This design's net to gross ratio is around 1.26. And a building with this shape may not be as exciting, but its core area is minimized compared to the usable space. Its net to gross ratio is only 1.14, which is about as good as it gets and is exactly the floor plan of 432 Park Avenue. While variety and expression in building design are important, these elements invariably add cost and require careful design consideration. When affordability is an issue, simpler designs are better. Wall-to-floor ratio is also a critical measure of cost efficiency. It expresses the perimeter length of the wall that has to be constructed for every unit of floor area, so from a cost perspective, the lower the ratio the better. Using simple geometry, we can see that a 3x3 square has a total perimeter of 12 meters. This would have a wall-to-floor ratio of 0.33. A cross shape with the same area of 9 square meters has a perimeter of 20 meters. This would have a wall-to-floor ratio of 0.45. When constructing buildings, this simple principle is the same. The more perimeter wall needed per floor area, the more expensive things get. A comparison of Asian and London towers provides an interesting contrast on approaches to wall-to-floor ratios. Tall Asian buildings score between 0.3 and 0.35, while London buildings score between 0.35 and 0.6, with the majority above 0.45. This is because the Asian buildings have larger, more regular floor plates with centrally located cores. So the design of our tower has huge effects on our cost, but so does construction techniques. Traditionally, towers are built using repeating floor design with molds called formwork being used to cast the concrete structure. Despite this essentially being an automated assembly line, it can still be labor intensive and slow and is exposed to variabilities of site and weather conditions. Prefabrication and off-site construction is increasingly becoming an appealing option. This can offer high-precision solutions created in factory conditions and often reduce on-site delays and help progress construction even in a market with a skills shortage. On some construction projects in Dublin already, concrete products and timber frames are being fabricated off-site and assembled on-site. An extreme example of this idea of prefabrication is being used in China, where a company called Broad Sustainable Building built a 30-story building in 15 days for a cost of just $1,000 per square meter, and later built another 57-story building in 19 days. The building pieces are fabricated in sections at 2 factories in Hunan. From there, the modules, complete with pre-installed ducts and plumbing for electricity, water and other infrastructure, are shipped to the site and assembled like Legos or flat-pack IKEA furniture. The company is in the process of franchising this technology to partners in India, Brazil and Russia. What it's selling is the world's first standardized skyscraper. One of the primary cost drivers for skyscrapers are the labor costs for specialized workers. By outsourcing much of the construction work to safer, controllable environments like this, we can reduce the costs. In a country like Ireland, where many of its skilled construction workers were forced to immigrate to Australia, New Zealand and Canada during the economic crisis, many of which have not come home, this may well be a solution that can help with construction. Regardless of building techniques, policies need to change in cities like Dublin to facilitate quicker, cost-effective builds, while not being completely blind to future implications of relaxing regulations. Currently, 1 car parking space per unit is required for any apartment. In a city centre location where we would hope to move towards public transport solutions, this is a completely unreasonable regulation to have in place, especially when you consider the impacts of cost it has, with some reports estimating that this adds €30,000 per car parking spot to any building. With our city populations growing more rapidly every year, we cannot hold on to past ideals. While the optimum height for minimising the cost of apartments may be 6 to 8 stories, we've discussed the benefits of building higher, beyond just the minimisation of cost, and how other cities have transformed themselves in a past video. Building higher facilitates cost-effective public transport, reduces commute times and creates a more livable city. We simply cannot continue allowing urban sprawl to be our solution. It is an unsustainable solution to a problem growing faster than we can keep up. We simply need to look at the ever-growing rate of homelessness in cities like Dublin for proof of this problem. In a city that lost hosting for the largest tech conference in the world due to a severe lack of infrastructure, the Dublin City Council deemed it sensible to refuse planning permission to this 22-storey hotel on Tara Street on the grounds that it would have a significant and detrimental visual impact on the city skyline. A skyline dominated by 2 industrial chimney stacks, while functional modern buildings that are desperately needed in the city are continually blocked. And this isn't a problem exclusive to Dublin. San Francisco, a city notorious for skyrocketing cost of accommodation, has an average building height of just 3 stories, mostly due to similar restrictions in building heights. Washington DC has some of the worst traffic in the US, and it has height restrictions blocking anything taller than its national monuments. In large cities with restrictive height regulations, you can almost be guaranteed socio-economic problems will follow. In all reality, this problem has so many facets beyond just engineering challenges. This is a problem that primarily affects young people, and those who already own their home have little interest in devaluing it by allowing high-rise developments near their home, and thus increasing supply. There are political motivations and many more factors that change why and how bubbles like this occur in different cities, but if we're going to build a sustainable future, we are going to have to rethink how we build and plan our cities. Perhaps we can start using machine learning algorithms to analyze and suggest changes to optimize our cities. Machine learning is a fantastic tool for when humans fall short of a complicated challenge, and you can learn more about it using this course on Brilliant. The first 3 classes in linear regression, linear classification, and trees are already available to get you started on what will likely be one of the most in-demand skills for future programmers, with other more advanced classes in things like optimization coming soon. Brilliant is a problem-solving site that helps you think like an engineer by guiding you through problems that are broken into digestible sections that bring you from knowing nothing to having a deep understanding of the topic. What I love is that when you answer something incorrectly, it even tells you exactly why, so you can correct your misconceptions. To support Real Engineering and learn more about Brilliant, go to brilliant.org/real engineering and sign up for free, and the first 73 people to go to that link will get 20% off their annual premium subscription. Just this month, we crossed the 1 million subscriber mark, and to celebrate that, I released my first personal channel video from a trip I took to Guam with Sam from Wendover Productions and Joseph from Real Life Lore. You can check that out with the link on screen now.